How has the concept of atom evolved? Let's take a journey through time and thought. The atom, so small yet the building block of all matter, has a story that stretches across centuries, shaped by imagination, experimentation, and deep curiosity. It all began over 2400 years ago in ancient Greece when Democritus, a philosopher, proposed a revolutionary idea. He believed that if you kept dividing matter into smaller and smaller pieces, you would eventually reach a point where it could no longer be divided. A tiny, indestructible particle he called atmos, meaning uncuttable. Though insightful, this idea lacked evidence and was dismissed by thinkers like Aristotle, and so the atom vanished from science for nearly 2000 years. In the early 1800s, John Dalton, a British chemist and school teacher, resurrected the idea, but this time with science. Based on his experiments with gases and chemical reactions, Dalton proposed that matter is made up of indivisible atoms, each element consisting of identical atoms, which combine in simple ratios to form compounds. This was the first scientific atomic theory, and it gave structure to chemistry. But soon, the idea of a solid, indivisible atom was challenged. In 1897, J.J. Thomson discovered the electron, a tiny negatively charged particle using a cathode ray tube. This idea this shattered the idea of indivisibility. He suggested the atom was a sphere of positive charge with electrons embedded inside, a model famously called as the plum pudding model. Then came a dramatic shift. In 1911, Ernest Rutherford, through his famous gold foil experiment, found that most alpha particles passed through gold foil, but a few bounced back. This could only mean that atoms were mostly empty space with a dense, positively charged nucleus at the center. Electrons, he said, orbited this nucleus like planets around a sun. His nuclear model was a milestone, but it had flaws. If electrons orbited like planets, they should spiral into the nucleus, destroying the atom. To fix this, Niels Bohr in 1913 proposed a new idea. Electrons orbit the nucleus in specific energy levels and can jump between them by absorbing or emitting energy. This Bohr model beautifully explained the spectrum of hydrogen and brought quantum ideas into atomic theory. You can see Bohr's atomic model in front of you. But Bohr's model did not last long. The atoms theory or story was not yet over. In the 1920s, Louis de Broglie suggested that particles like electrons also behave like waves, blurring the line between matter and energy. Warren Heisenberg added to the mystery with his uncertainty principle, which stated that one can never know both the position and the momentum of an electron precisely. The neat orbits of Bohr suddenly seemed too simple. You can see Heisenberg's theory compared to that of Erwin Schrödinger. The most accurate model, the quantum mechanical model, was developed by Erwin Schrödinger in 1926. Using wave equations, he proposed that electrons do not orbit the nucleus in fixed paths but exist in cloud-like regions called orbitals, where the probability of finding them is highest. Atoms were no longer seen as miniature solar systems but as probability fields, strange, fuzzy, and deeply mathematical. In 1932, James Chadwick discovered the neutron, a neutral particle in the nucleus that explained the rest of an atom's mass. With protons, neutrons, and electrons accounted for, the atom finally seemed complete. Yet, even this was just the beginning. In modern physics, we have discovered that protons and neutrons themselves are made of quarks bound by gluons, and that reality is governed by even deeper quantum fields. From Democritus' atomos to Schrodinger's equations, the atomic theory has undergone a stunning transformation. From ancient guesswork to the bizarre and beautiful world of quantum mechanics, the atom, once imagined as solid and simple, turned out to be one of nature's most mysterious masterpieces. Thank you so much for listening.